I'm currently working on another setup here for our Flex, and we got this guy set up right here. So I got 2 of these plates that I need to machine, and I just finished getting our fixturing set up here. We've got 3 of these 1x3 flat bars, and the one here on the left side has got some dowel pins pressed into there that you use to register the left side of the workpiece here. This bar here is part of a fixture that we're going to be setting some plates down. There's actually 3 of them, but these 2 dowel pins on this side is what aligns the plate once it gets set down here, and then you have another dowel pin over there that's going to be for your Y, so it pushes back and to the left against these dowel pins. I'm using a straight edge, setting on some setup blocks there, and just getting that edge indicated. And I think I got it within 1/1000ths there. We'll go ahead and move it back across to the other side. So with that 1/1000th resolution, I'm within about a 1/2 or so on end to end. So I think that's going to be pretty good right where it's at. It's going to work just fine. So make sure that we get those 3 bolts snug down properly. There's also another dowel pin back here on the center bar. So once this is indicated nice and true to the Y axis there, and everything is spaced out accordingly, just set the plate in there, clamp it down, set the plate in and push it against these dowel pins on the left side and the dowel pin on the right, and then we'll X0 the left side and Y0 the back side right there. It actually works off of this corner coming out this way. So there's going to be a series of drilled and counterbored holes. That'll be the hold down bolts to hold it down to the table. And then there's a bunch of drilled and tapped holes in there as well. I got 2 of them to do. This one's going to be my first test piece there. I'm going to get the program loaded up and see if we got any success on making this guy happen. And once I get all the bugs worked out and we know we got a good program to run, we'll get some video of the machining action here on the Flex. All right, we got our Heimer 3D sensor set up there. We're going to use that to find X and Y using our hand pendant here. X, all right. Take it down to tenths and just bring that line up to 2 zeros, just like that. This is going to be our X0. So this is going to be set up as G56, our 3rd work location. So we've got that line highlighted, and we'll just simply come down here to X. Set work offset to current machine position. Okay. All right, there we go. Now we match the machine coordinate right there. Now we'll do the same thing for Y. First thing we want to do is back off. Bring our Z up to clear. All right. Let's move down a little bit. Got to move the controller. Let's go plus and our Y. All right, this is where you got to kind of like lean in here to really see it. It's so far away. That's one of the things about the Flex, is that you got such a big machine bed, you got to lean out there or lean through the window here. You can only do that in manual mode. It won't let you run it. All right, let's see. We want Z, negative. Let's bring it back in a little. Somewhere around there. Let's move down a little bit closer to our dowel pin. All right, we'll slow it down. All right, bringing it in. Slow it down to tenths. Okay, 0, 0. Let's set Y. Okay, so over here on the controller, we're on G56, and we are going to hit Y. Current machine position, okay. And we are now set, that matches. Now we still need to do Z, so we'll do that next. I've been having problems getting tools set correctly using the 3D sensor for Z your tool position. So what I like to do, we're going to go ahead and let me see, just let's go ahead and back off of that and bring this up. First thing that you want to do. So I've got a tool position or a tool setter that I use in order to set the tools over here. I'll show you that next, but I'm going to go ahead and get this pulled out of here. So we'll go ahead and grab tool number 1. That's the tool that we're going to use set our tool setter and set our Z position. All right. This is where it's giving me a warning, letting me know that if there's a tool in the spindle, it's about to drop it if you continue. You have to hit yes or no, but we want to continue. There's nothing in the spindle. Lined up on tool 1. There we go. Let's go ahead and bring it over here closer to us, and we'll get the tool setter over here. So this is the tool that I've been using over here to set our Z, our Z position for our tools. It's a tool setter made by Edge Technology Products, and it works great. I've already calibrated it, or I checked calibration, and it is in fact on 4 inches. And all you do is you bring your tool down on the indicator there on this pad and line it up on that 0 as close as you can, and that should be exactly 4 inches there and about. You know, but it is set to 4 inches, depends on how flat your workpiece is. So we're already a little bit too low right there. So I'm going to go back to pendant, acknowledge, MPG, and we want Z up. All right, then we can get this. Now there's a burr. There's a burr there. Let's, yeah, something hit it. So that feels pretty good. I think what we'll do is we'll just move over right there. Go a little faster than that. All right, I think we're about ready to go right there. Just trying to center it up on there. Okay. Now, first thing I need to do is activate H1 on the MDI here. So since we're using tool number 1, we have to use the H1 value in here. We're set up on tool 1, but we need to go to MDI. And I've already got an H1, and then all we're going to do is just hit cycle start. And all that is just going to activate, and now our tool is tool 1, H1. That was an important step that I had missed before, and now I've learned how to do this. So we'll go back to manual, but I'm going to go over to the pendant control here, and we'll use that to go ahead and get our indicator on 0. All right, here we go. Z times 10, just using the pendant. When I get it close, I switch over to tenths. We were on thousandths. All right, it looks like from here, it's lined up on 0. Let's go back to the controller. All right, back to the control here. Let's go to our work offset. And we're using G56. So we want to highlight G56, that's our work location, and we're going to hit Z, yes, and it's going to ask you to subtract tool number 1, that's that H value. There it is right there, subtract H1 from the Z-axis work offset, yes. All right, so we're not there yet, and what we have to do, since now we know we're 4 inches between the tool and the top of the work surface there. We're just going to put our cursor right at the back of that box, because this is our Z, and I'm going to hit minus. See the box popped up. 4 for 4 inches, enter, and it wants to subtract that from our where it's at currently. We're going to hit OK, and there it is. Now it moves down whenever you end up at Z right there, but we'll go back there and highlight. So that's going to be our current work location for Z, and that should be the very top surface of that workpiece right there. Now, before I run the program, I will verify that by bringing a tool down and making sure that the 0 point of our cutting is actually right there on that face. And I'll do air cuts on this as well. So we'll actually come back in where we just were when I did the -4 inches. And I'll probably just add like 2 inches to this here so that it brings our tool 2 inches up, and I can go around and verify that everything is looking correct, that we're on the right, you know, XY coordinates for our work location and all that kind of stuff. But I think we're ready to go ahead and get this program proven now. Okay, I think our program is ready to go. I just went through the air cut process. I raised our Z up 2 inches and did the air cut, went through the whole cycle to make sure everything looked correct. And even though I haven't made any chips, the motion of everything looked good. The feed rates looked good. So I hope we got a good program. So I'm going to show you the tools that we're going to be using for cutting this, and then we'll get started on it. So everything is looking pretty good. I do want to go ahead and show you what this is going to be. So this is a cart top that's going to belong to Flex, or a Flex arm. Okay, this was a project I talked to them about a while back to see if they had something like this they could send me and I could do as a demo and a little bit of a practice session because I have a couple other fixture plates I want to make. So they sent me 2 of these. It was already Blanchard ground, so once this is machined here, I'll send it back up there, and then we'll have 2 of these carts that they can put on one of their Flex arm carts. So this is exactly what we're machining right here. Same exact model and everything. So we actually have 4 holes that is drilled and counterbored in the corners. So that's to mount it down to the cart. You have a big series of half 13 holes that are tapped in there. And then we also have these mounting holes here for the Flex arm. And these are tapped 3/8/16. So that's all we're doing, but because there's so many holes, this is going to take a little while to cut. It's not going to take an hour, but I think it's going to be close to an hour of machine time. All right, so I have this guy right here, and as I said, they did send 2, so here's the other one. All right, if we have good luck with the first one, we'll clean it off, and we'll have one more to cut. And then what I'd like to do is set this guy up. So this is going to be another job that I'll work on. It's going to be the same thing, it's just a little bit bigger. And what I want to do is I have the big hydraulic Flex arm at my home shop. It's got the big hydraulic power unit. I would actually like to use that here. We have a 480 volts up there, that transformer. So I'll be able to use the big Flex arm here. And then, so I got this cart from Flex arm that we can mount that on. The power unit's going to go down below right there, and then we'll have a receptacle back there that we can plug it into whenever we want to use it. I'll most likely take this one to the home shop and have that one there. That one is a pneumatic Flex arm there. But I told him, I said, leave the cart top unmachined, and I'm going to go ahead and machine it myself over on the Flex arm. So that's what we're going to do. So this will be coming up pretty soon. I'll have to make some more fixturing like we've got for this other cart top here. We'll get some flat bar and just kind of mimic this right here. It worked out really good, and we'll have a setup like that for the bigger cart top. Let's take a look at the tools, show you what we're going to be using, and then we'll get over here and start making chips. These are all the cutting tools that we're going to be using in the Flex today. So our drills are Walter Titex. We've got a 9/16 that we'll be using. This will be the clearance hole for the mounting bolt locations. So drill it with a 9/16 there. And then we have this Walter Titex 27/64. So this is your tap size for the half 13. Both of these are through coolant, by the way. So we're using through coolant on those. And this guy right here, so this is a new end mill from IMCO. A few months back, I won Instagram Chip of the Week, and then I ended up winning the Instagram Chip of the Month. And IMCO was the sponsor for that Chip of the Month win. And what they did was they sent me a couple of t-shirts, but they also said, hey, we'd love to send you a couple of these new power feed end mills for you to sample out if you would like. I said, absolutely. So they sent me a couple of these. There's a look at, I've got one already installed, and this is the other one here. All right, I've never run any of the IMCO brand in mills before, but I know that they're going to be a high quality cutter. And I actually got to meet a couple of these folks at the last IMTS. A good group of people. I really enjoyed talking to them. So we're going to be doing that. This is going to be used to counterbore the 4 mounting locations for the 1/2 inch cap head bolts or socket head bolts that's going to be used to mount the plate down to the cart. This, I don't actually have it because I only had 2 of these and the other one's installed in the Milltronics, but this is a 3/8 diameter mill drill and we'll be using this for all of our chamfering. And I don't think we're not spotting any holes, but we're going to be using this to chamfer all the holes, okay? And then we have our 2 taps. So these are going to be the OSG Hypro. We have a 1/2 13 that we're going to run. Just like that. All right, and then the same thing except 3/8, a 3/8 16. So spiral pointed, or gun tap you might call it. And that's going to be our cutters. All right, so let's go see if we can make some chips now. All right, getting all set up here. We got our camera set up. I thought I'd show you this. I put a GoPro sticky mount up here on the spindle so we could run a second camera to help capture some of the footage down here in the machine. It's not perfect because coolant does splash up on it, but there's really nothing I can do about it right now. I know people have developed the air blades that they put. I think they have a special case with air that blows the coolant away from it, doesn't stick to the lens, but I don't have that right now, so we're just gonna roll with what we got. We have almost an hour of machine time that we're gonna be doing on this plate right here, so I plan on just turning that guy on and just letting it run, and we'll see what kind of footage we get there at the end. I do have this little GoPro light here that kind of helps out a little bit, helps brighten it up inside there. I have this light over here as well, that's on, and it should be good enough for what we're trying to do. All right, so let's get her closed up. Help if that one worked right. There we go. All right, let's make some chips. So we're currently running the 27/64 drill bit, and I gotta say it's working great. That first drill was our 9/16, and it went through like butter. This 27/64 is going through that steel like butter. They do a really great job. I forgot to mention that that first set of holes we drilled is actually 5/16. I forgot to mention that, so we had that drill in there as well, but that was tap size for our 3/8 bolts. That drill is just performing exceptionally well, and it's working beautifully. Not quite sure how the footage is turning out on the onboard camera there, but it looks really great here. I love having that extra light in there shining down on it. That's my Freelux light, made by Freelux. It's looking really good. We're on our last row of 27/64s. All right, this is going to be our 1/2 inch end mill counterbored. That seemed to work pretty good. The two holes on the inward side seem to have a little bit more chattery sound over there. I'm not sure why. Maybe it's because the fixture's overhung that side a little bit more. That's my suspicion. All right, what do we have next? Next up's a chamfer mill. So we're gonna go ahead and chamfer every hole, get them all chamfered, and the last phase will be tapping. Chamfer mill's looking good. Looks like it's doing a good job. So I know that the order in which it's chamfering is not going to follow the same tool path as when we drilled it or when we're going to tap it. And that's just how the program decided it wanted to run the cutter. So we're just running the cam software as it wants to go. But it's working good, mill sounding good. I'm liking it. All right, we just finished all of the chamfers, and what I want to do is get in there. I want to clean the camera lens off, and I want to clean this window off there as well. So I believe what we can do, I've been asking Aaron if this is going to work, and he said yep. So we need to go to, so we're in auto right here. We need to go to manual mode, because the next thing is going to be our tool change right here. So we'll go to manual. Y, bring it over here to us, and I can open the door, and that's not going to cause any problems with the program, because if you open the door with it running, it's going to stop, and then you got to start over again or find a line to start. So there you go. All right, this will give me a chance to get in there and kind of look at it too. Everything is looking really good. Camera's still rolling. So we'll get that guy cleaned off, and then next up is going to be tapping all the holes. All right, we got the camera clean. We'll go ahead and turn it back on. Flashlight's still on. By the way, my little light for the GoPro died as soon as, when I was getting ready to start it, it died, so I just took it off there. We got the glass cleaned off again. So we should be ready to go back to auto and hit cycle start. So next up is our 3/8/16 tap. Get those holes tapped, and then we'll do the 1/2-13. This is the one that always makes me the most nervous right here, is our tapping. So far, so good. All right, the 1/2-13 is in there doing its job. Everything's sounding, looking good. Real happy with that. Looking good. So this is going to take a little while. You can see we're at 41 minutes, and I think it's going to take it all the way to 57 or 58 minutes total once the whole plate is completed there. Some of that chattery noise that you guys hear is actually that auger down there. Those chips get in there, and it just makes a little bit of racket. Everything's still sounding good and working good. 98.6% done, 3,450 lines out of 3,500. This time it's higher because of that time that I actually stopped there and was in the machine. When I did my air run, I think it was 57 minutes total. 2 more rows of holes and this guy will be finished up. Let's have a look at our first machine fixture plate here. Looking mighty fine. Chamfers look good. Some of the threaded holes don't look as good as they should be. That's a concern there. I'm gonna have to blow them out and check them. Yeah, I don't know if that's gonna fly, guys. Don't know. How's it look over here where we started? I just need to get an air hose over here and blow it off. Everything's looking good besides those threads and those 1/2-inch holes. So I don't know if it's gonna work or not, but I need to get it cleaned off so I can get the coolant blown out of the thread so I can take a better look. All right, well, we got her cleaned off and doing some inspection of the threads. They all pretty much look the same, including the 3/8/16. They look a little bit rough too. I just pulled the 1/2-13 tap out and I'm inspecting it, and it doesn't look good. That tap does not look like a new tap anymore. It's just got signs of it's got some wear in there. At this point, I'm not exactly sure what's going on with this. I've tapped a lot. I've already tapped on this machine before and I haven't had any issues. I've tapped in that machine a lot, no issues. So this was really surprising to see how these tapped holes are looking. You got some of them that have a little bit of a burr coming out of them. I'm wondering it has something to do with the tap cycle. You know, maybe the tap isn't staying in perfect alignment with the lead, the movement of the Z-axis. That I'm not sure about. I do know that a lot of people run an actual tap adapter, a tapping head that's supposed to have a little bit of axial float give to it so that the tap can stay in line with the threads. I got a feeling that's probably what I'm gonna have to use over here on the Flex. So maybe it has something to do with that. I'm gonna give those guys a call though and talk to them about this issue with the thread and see what they have to say about that, and if they suggest anything. You know, if they think that I need to run an actual tap holder in here, one of those tap drivers, spring-loaded tap drivers. But I don't like the looks of that tap right there anyway. Our counterboards look beautiful, our chamfers look beautiful. It's just the threads themselves are not that good. So I believe this plate right here is probably just going to stay with me because those threads are not going to fly. We can't send that out for somebody on a Flex arm. And since I have one more, I have another shot at this. So I'll probably just wait and revisit this when we can do some figuring on what I need to do to improve our threaded holes in this plate right here. Okay, I talked to Aaron over at Flex, and he's gonna be getting with the engineers over there. They're probably gonna have to get in here and access the system like they do, that they've done before. And he says this is possibly something that needs to be adjusted in the actual controller in the software. It may be something where our Z-axis is not perfectly timed with the rotation of the spindle. So that's something that they are going to work on and see if we can get that. He did also inform me about those floating tap holders that we can get. They run some by Technics, so I'm going to look into that. That'll probably fix this issue right here, but it's definitely something that Flex is going to jump in here and take a look at. So it looks like as far as this one goes, I've got me a spare fixture plate there. All we got to do is just chase these threads, and we'll just use our flex arm there to just chase all of those holes, and that'll be good enough to use for some kind of work surface around the shop. And we got one left right there that we're going to do, but I'm not going to machine that until we make sure that all of our tapping capabilities are up to par here on our Flex. So that's going to finish up this project right here, but it was another good exercise for me. Every time I get over here and use this machine, I'm a little bit more familiar with it and remembering how to actually operate it and use it and control it and use it for some of its capabilities, which is larger work surfaces like this or work pieces, and having multiple workstations along here that you can do lots of different jobs. All right, so that's it for today, and I hope to see you on the next video. An update on the Flex CNC since that last video clip that you just saw, and our tapping issues that we were having with our fixture plate here. So we've got the second one set up. I haven't touched it yet because I wanted to make sure that we have this issue resolved before I move on to any more work. And that's what we've done. So I relayed the info and some photos to Flex Machine Tools. They instantly jumped on board, contacted me and said, just hold off. There's something that we need to check and inspect. And one of their software engineers team viewed into the computer, did some checking. I don't know what they were doing, but I saw them in there working, and they made an adjustment somewhere. What they had to adjust, I can't tell you because I don't know, but they made an adjustment. They called and said, okay, it should be good to go now. Go ahead and tap some holes and let us know, what's up. So I set up one of these fixtures here that I've already machined. This is one of the ones I'm not going to be using, so it's just a drop at this point. And I went ahead and drilled 2 half-13 holes there. I drilled and tapped a 3/8 hole there, and I think it is exactly where it needs to be now. The threads, I know you can't see it with this camera very well, but the threads in there are beautiful. Same thing with a 3/8 hole. And I actually have my go no-go gauges with me now. So this one's for the half-13. It is screwing into the hole just like it should. So the tap is working just like it is supposed to now. We put it on the no-go side, it will not screw in there. But I'm telling you, the threads are beautiful. All right, we'll go ahead and do the same with our 3/8/16. Thread in there just like it's supposed to. And again, you can visually see that the threads are right now. Now they actually have a nice, shiny, polished look to the cut. So since I had messed up, or the tap that we were using for the fixture, that was that OSG tap, it obviously has got some it's got some wear on it. So I went ahead and reinstalled the Walter tap that I had before, put that back in the machine, and that's what tapped these holes here. And it is on, it is ready to go. So it was something with the settings and the software, and the engineer had asked me, is this the first time that you've done rigid tapping? And I said, yeah, we've run some jobs on here, but I haven't done any rigid tapping before until I got to this and this right here. And that's when I noticed the issue. So they were able to correct it, and it's doing beautiful now. So I just wanted you guys to know that the machine is now working as it should. They just had to get in there and adjust it. We just never ran into this because I hadn't done any rigid tapping on it until this point. All right, but I also have a couple of holders coming too. It's those tension compression holders that you use for tapping. It allows for some axial misalignment of the tap. When the spindle's coming down and it's tapping the hole, it has a little bit of float in there, so that if the alignment is off with the spindle on the rotation and the Z movement, the float in the tool holder allows the tap to stay completely aligned with itself as it's coming back out or in, either way. So we're going to be trying those holders. I'm going to wait until those get here, and when I do, I'll get those set up. We'll show what those look like and how they work, and then we'll jump back onto this fixture plate and give it a second shot, because I want to make sure it's right next time we jump on board. So I just wanted you guys to be aware of the issue that we found, and that it has been resolved since then. So I'm looking forward to getting back on this one and making a good fixture plate out of that second piece right there.